Let's look at this question. This question says, a student walks a distance of 3 kilometers in 20 minutes. Calculate its average speed. So this question is saying, how fast was this student? That's the meaning of this. What is the average speed? Mathematically, speed is equals to distance over time. Okay? That is a known distance over the time to complete the distance. So now, what is the distance? The distance we have here is simply 3 kilometers. Please learn to put the unit in your solution. All over 20 minutes. Okay? Now, what is the unit of speed? Speed is meter per seconds. Okay? Now, what we have here is kilometer. So first of all, let's remove the K. What is K? 1,000. We replace this by 1,000. Then we put the meter all over 20. We need to change this to seconds. What is changing minute to seconds? That is multiply by 60. So once we multiply by 60, we are moving from the word of minutes to the word of seconds. Okay? Now, we can see this cancel this. This cancel this. 2 here 1, 2 here 5. This multiplied by this is 15 over 6. 3 here 2, 3 here 5. 2 here 1, 2 here 2.5. It means, therefore, our speed is equals to 2.5 meters per second. So this is the speed of this student. Let's look at this. It says, a driver traveling at a speed of 115 kilometers per hour received a text message on his mobile phone. Let's analyze that. You are driving, and your speedometer is ready 115 kilometers per hour. You are just on that speedometer. You are not reducing the speedometer, you are not increasing it. Just continue with the same speed. While you were driving, you received a text message. Bang. Then you continue driving. While you were driving, at this point, you receive a text message. When you receive the text message, you did not stop driving at this speed. You continue driving at the same speed. Okay? The question is saying, how far is he in kilometers? 20 seconds later. Let's say from here to here is the 20 seconds later. 20 seconds as per time. But the distance we are not talking about yet. We don't know what is the distance for now, but we know the seconds, the time. From when he received the test. This is when he received the test. So the question is, say, how far in kilometers? We are looking for this distance. We know the time. We know the speed at which he was driving. Continuously, he's still driving it. Still driving. You will agree with me again that speed is distance over time. Okay? Now, we want distance. We are looking for distance because we know this. We know this. Okay? So now we are looking for what? The distance. To get the distance, simply what? Cross multiply. 1 multiplied by this is distance equals to this multiplied by this is speed multiplied by time. Okay? Now, what is the speed? 115 kilometer per hour. Learn to put the unit. Multiply by time. Time is what? 20 seconds. Put the seconds. But now, this is kilometer per hour. This is in per hour. This is in seconds. In the realm of time, we have hour, we have minute, we have seconds. If you are working on any question, make sure that what? There is what? Uniformity. As far as this hour and seconds are concerned, they are not compatible. Either you go to seconds or you go to hour. We are going to go to hour. I can decide to go to seconds. Okay? Now, if I need to go to hour, that means I have to convert this to hour. Then leave this one as it is. If I want to go to seconds, I should come here to convert this denominator to seconds. That means I have to do meter per seconds. Replacing this k with 1000, then this denominator by 60 multiplied by 60. But we are not going to do that. What we are doing, we are going to convert this to hour. Now, let's leave this as it is. Kilometer per hour multiplied by 20. How do we convert seconds to hour? We divide by 60. Another 60. This one converts this to minute. Why this converts this to what? Hour. Now we have this in hour now. So you agree with me? This is now 115 multiplied by 20 over 60 multiplied by 60. Okay? Finally, the unit is now what? In kilometer. How? Will that confuse you? Let me explain to you. This is what? Kilometer over hour. Multiply by hour. Hour cancel hour. This is remaining. Okay? Now, this cancel this. This here 1, this here 3. Now we have 115 over 180. If you divide this now, you're going to have 0.6388 and so on and so forth. We can simply approximate like this in kilometer. That is our distance. In case you were asked to solve this in meter, all you have to do, you multiply this by 1000. Okay? Hope you understand the process. Thank you for viewing. Let's look at this question. It says, a particle accelerates uniformly from rest at 6.0 meter per second square for 8 seconds. As you can see, this is acceleration in meter per second square. If you want to solve a question like this correctly, as you are reading, plot the graph. That is velocity time graph. This is the velocity line. This is the time line. This position you are seeing here is 0. Why am I starting with 0? Or starting from 0? Because I saw from rest. From rest. Rest is 0. It accelerates uniformly. Uniform acceleration means it was going like this. That is, as this velocity is increasing, time was increasing. This is velocity. Change in displacement with time was increasing. Time was increasing. That is, as it's going here, this is increasing, increasing, increasing. That is, if you plot the graph, you have something like this. From rest. Okay? Therefore, you can plot it like this. Say this is V, this is T. What I will do, I will simply write this on the graph. Not here, because this is velocity line, this is time line, This is the acceleration line, that is 6.0 meter per second square. Okay? After that, then decelerates uniformly to rest in 5 seconds. So from here to here, it was 8 seconds. Here now, decelerate, going down. The velocity is now reducing while the time is still moving. Your clock never stops. Clock never stops. Decelerate, that is slowing down. The velocity that was here, high speed, the speed is now reducing. It's reducing. As it's reducing, time is reducing. So we plot the graph, we have something like this. So here, 5 seconds. Let's redraw it. Say somewhere here, 5 seconds. So this is the acceleration side. This is the deceleration side. Because there was no constant velocity. So we can't do something like this. Because nothing was constant. Up, down. You have this picture in your mind. You must not draw it out. Determine the magnitude of the deceleration. So you can see, this value was given to us to write on this graph. Nothing was given to us here. What was only given to us was the time. The distance was not even given. How do you solve this? Very simple. Let me show you. Acceleration or deceleration is always A equals to the final velocity minus the initial velocity all over time. The velocity at which you started from, the velocity at which you stopped. So, these guys stop here, but started from 0. This is one leg for acceleration. We are going to consider it separately. Then we go for the second leg, deceleration. We consider it separately as far as this is concerned. So what we need to do now, we are going to solve for what? We are going to solve for final velocity. So we are going to do over 1 cross multiply. This multiplied by this is 80. This multiplied by this remains this. Then you move this to this side to have 80 plus u equals to v. You can rewrite this as v equals to u plus 80. This is our final velocity. Why am I interested in the final velocity? Because whenever you are solving anything acceleration, you must know the initial and the final. Anything acceleration and deceleration, you must know the starting point and the ending point as far as the velocity is concerned. Okay? Now, for this leg, we know that it started from rest. So we can say that the beginning was 0. But the final was not given to us. Why do you need the final? I need the final because when I want to consider this other side, which is deceleration, deceleration also needs the starting point. Where did it start? Decelerating. I don't even know. Why? Because if you look at this place now, there is no value for velocity. Look at this question. Is there any value for velocity? No value for velocity. But here I know, starting from rest, I know the starting point as far as acceleration is concerned. But I don't know the end. It is the end of the acceleration that will be the beginning of the deceleration. You understand? If, for instance, this was 6, this is the final velocity for the acceleration. And it's also the initial velocity for the deceleration, because as at this point, this is where acceleration stopped. This 6, assume it is 6. And it's at this point it starts decelerating. That is the starting point for deceleration is 6. What are we looking at? As far as deceleration is concerned, this will be the u, initial velocity. Why this for acceleration is 0. But this ending point for acceleration, this is the final for acceleration. What it is the initial for deceleration. Now, as far as this question is concerned, What you are looking for here is A for this side. We know A for this side, but we don't know A for this side. I can decide not to even do all this calculation. I say all I want to apply is simply acceleration is equals to V minus U over T. I'm looking for A for this other side, right? Next question is this. We don't know A for this last one. We know 5, right? We don't know the initial velocity, where it started from. Remember, I put this one for illustration purpose. We don't even know where this starts from. Before it starts decelerating, the beginning, we don't know. This is the beginning of the deceleration. It's not given to us. How can we get it? We can get it if we can get the final of this one, the final. This is the final. So let's go and calculate the final of this acceleration to get this beginning of this guy. So now, if we come back here, you agree with me, apply the same formula, A equals to V minus U over T. A here is 6. T is 8. The final, we don't know. The beginning we know to be 0. Now you can now solve for V. You get it? We know the acceleration. We know the initial starting from rest. Rest is 0. We know the time 8. We are looking for V. Okay? Now you can cross multiply to say this multiplied by this is what? 6 times 8 equals to this minus this is simply V. 8 multiplied by 6 is 48. So V is equals to 48 meters per second. As you can see, this 48 is what we have here. Remember the 6 I put there before was for illustration purpose. It's 48 we have as the final velocity for this acceleration. That is where it stopped. The maximum, where you were running. You stop at 48. When you get to 48, you start coming down. We are not saying, when did you start coming down? I started coming down from 48 meters per second. That is your initial for the deceleration. So therefore, if I come back to this place now, my initial, remember here, I use it for V, my initial now is 48. Okay? My time is already 5. What of the final velocity? What is the final velocity? I want to ask you, look at this. The final velocity here, I started from here, going down. What do you think is the final here? The final, if you come back, is 0. Because you were running before. You start coming down. As you are slowing down. 48, 40, 30, 20, 10, 2, 0. You stop. So here will be 0. Your final here will be 0. Okay? Therefore, we are looking for 8, as you already know. So this is minus 48 over 5. This will give you 9.6. That is minus 9.6. 9.6 what? In meter per second square. As you can see, the value is negative. Why is it negative? Because deceleration is negative value. You are decelerating. Okay, so is minus 9.6 meter per second square. Hope you get this explanation correctly. Hope you get it. Let's look at this. It says a body accelerates uniformly from rest at the rate of 3 meters per second square for 8 seconds. Calculate the distance covered by the body during acceleration. The distance covered by the body during acceleration. Now, one thing you must put at the back of your mind is there are 3 important equations of motion. 3 important equations of motion. These are V equals to U plus AT. Another one is S equals to UT plus 1 over 2 AT squared. Next is v square, u square plus 2as. If you have to cram this, cram them. Because to actually get this, you have to prove it. So cram them. Even this, you have to prove it. Cram this formula all the time when you are dealing with motions. Okay? V is final velocity. U is initial velocity. A is acceleration or deceleration. T is time. S here is what? The distance. S, not speed. Distance. U is initial velocity. T, time, as I've explained. Now, how do you know the formula you should apply? You will know from the question. From this question now, what are the given and the unknown? You will agree with me from here. We have a body accelerate uniformly. So we have A, time is given, okay? Calculate the distance. The distance is S, okay? Covered by the body. So among this is known, this is known, this is not known, okay? Among this, which of them has all this? Remember, there's another one given to us that escaped my eyes. From rest. From rest means U is given. Initial velocity. Okay? Now, among this, which one has all this? The first one doesn't have S. The second one has S. It has U. It has T. It has A. It has T. This last one has everything but no T. So it means therefore this is the one that is applicable to the question. Okay? Now let's solve. We are looking for the distance x. Initial velocity from rest, that is 0. The t is given to us as 8. 1/2 multiplied by acceleration 3. Okay? What about the time again? It's 8. You put 2 square at the top. You agree with me? This is already 0 plus 1/2 multiplied by 3 times 64. 2 here 1, 2 here 32. 3 times 32, you get 0 plus 96. At the end of the day, our S is 96. What is the unit? The unit can be achieved from here. That is in meter, not kilometer. 96 meter. Hope you understand it. Please watch all my videos. You will see I'm applying different strategies. The first one, we're using this first equation. Not directly like this, but in another format. Watch all my videos. Don't forget. Share, subscribe, follow, tell people, your family and friends. Just make it everywhere. Let's go for the next question. Thank you. Let's look at this. It says, starting from rest, when you are dealing with physics question, motion, when you see the word from rest, they are already giving you a tip that we are looking at U to be equal to 0. Initial velocity. Okay? A Formula 1 car accelerates uniformly at 25, that is A. For 30 seconds, that is T. Okay? What distance? S is distance. S, that is X. Does it cover in the last 1 second of motion? That is T. 17 seconds of motion. That is T. What is the purpose of me assigning these symbols? Because in motion, we have 3 equations, which you should always know. If you like, memorize them. Is V as equals to U plus AT. Speed as equals to UT plus 1/2 AT squared. Why V squared equals to U squared plus 2AS. These are very important equations you should have at the back of your mind. The next thing is, looking at this question, which of them should we use? As you can see, any of them we should use must have all these parameters. The first one, something is missing here, that is S. We cannot use U. The last one, something is missing, T. We cannot use U because T is here. What we can use is this S. S is here, U is here, T is here, A is here. So therefore, we are going to use what? The second one. We say that what? S is equals to ut plus 1 over 2 at squared. Okay? Now, what distance does it cover in the last 1 second? In the last 1 second. But we are looking at 30 seconds. Last 1 second. Okay. If it was moving, this is the time. Let's say this is 0, 1, 2, 3, 4, 5, 30 seconds. This is 29. This is 28. The last 1 second is this distance covered between 29th and 30th. Between 29 seconds and 30 seconds. Apply this formula, it means we are going to use 2 times. The distance is covered from here to here, that is from beginning to 30, minus from beginning to 29 to get this remaining one. Because if you don't include the beginning, we can't use the U because we need to use the U. Starting from rest, we can't drop this. You say, why are you saying from beginning to... No, when you simply say this minus this. If you say this minus this, what was the speed at 29? The only speed we know, it was from rest, 0. So everything must be connected to the back. Therefore, the speed or whatever you want to calculate is at 30 at 29. From this to 30. So this is what we are looking for, the distance covered between this period. So therefore, we are going to say the distance we are looking at is the distance at 30 seconds minus the distance at 29 seconds. Okay? So first of all, let's get the distance at 30 seconds. So S at 30 seconds is equal to U from 0, that is from rest, 30, plus 1 over 2 multiplied by A. A is 25 multiplied by T, which is what? 30. Distance at 30 seconds. If you solve this now, you agree with me, is 0 plus, please note this is square. Okay? Now, if you come here, that is 25 multiplied by 30 multiplied by 30 over 2. So I will simply say this is equals to 25 times 30 times 30 over 2. I will stop here. I will go again for that of 29, which is 0 multiplied by 29 plus 1 over 2 multiplied by 25, which is the acceleration, multiplied by 29 squared. At the end of the day, distance at 29 is, this will give us 0, 25 multiplied by 29 multiplied by 29 over 2. Now, the final answer is distance at 30 minus distance at 29. That is, what we are looking for is equals to 25 30 times 30 over 2 minus 25 29 times 29 over 2. You will agree with me 25 is common and 2 is also common. What is not common is this. Okay? So now, this will give us 25 over 2. This is 30 multiplied by 30. That is 900, 841. This will give us 25 over 2 multiplied by 59. Because this will give us 59. Okay? This will give us 1475 over 2 equals to 737.5 in meter. A meter. This is the final answer. This is not difficult. Okay? Not difficult. That is the last 1 seconds of motion. For this one, it says the 17 seconds. 17 seconds. All you have to do, connect it to the beginning. So from beginning to 17, say this 17. For this 17, to get it exactly, we must know that of 16. This is what we are talking about here. So we have to connect them to the beginning. Connect them to the beginning. Because this is the initial. The way we did this. So what I'm going to do now, I will allow you to solve this. You share the answer with us. The same process. First of all, you do for 17 the way you did for 30th. Then you do for 16 the way you do for 29th. Then you subtract and get your final answer. If you have any question, do not hesitate to ask. Drop it in the comment section. Thank you. Let's look at this. It says, a body uniformly accelerates from rest at 8 meters per second square. In how much time will the body travel a distance of 2.5 kilometers? A body. Could be a car, could be somebody running, it could be a flight. A body is a body. As far as motion is concerned, it could be anything that we are describing with body. Sometimes we say particle. Okay? The first thing you should do here, learn to assign the right symbol. Uniformly accelerate from rest. From rest means initial velocity is equal to 0. Acceleration, A. How much time, the question, T, will the body travel a distance of this, that is S? Among the 3 equations of motions, which are V equals to U plus AT, distance equal to UT plus 1 over 2 AT square, V square equals to U square plus 2 AS. Among these 3, which of them do you think has all this information? Which of them? So you can see, it is this one, without wasting our time. Because S is here, U is here, T is here. This one does not have S, this one does not have T. So this is the one that is qualified to be used. So, what are we looking for? We are looking for time, T. Is this time given to us? Yes. So for this first part, 2.5 is given. In kilometer, let's put the kilometer. So that we will not forget that there's K here. So people might just, oh, it's 2.5 kilometer. If it's an OBJ question, that's objective question where you need to select with options, you might miss it. So either from beginning, you put everything in kilometer and time in hour, or in meter and seconds. From here, we have seconds. So why not better convert this to meter? Because we already have meter per seconds. Therefore, you agree with me that this multiplied by 1,000, where is this coming from? The K is what? 2500. So therefore, I can replace this with 2,500. Here we have meter. So that when I'm using this acceleration, I will not be having guilty conscience of why are you missing hour and seconds, or why are you missing kilometer and meter. So this is not equals to, the initial velocity is from rest. Rest means 0 multiplied by T, time. And the time is what? In how much time? That is the question they're asking us. We don't know. 1 over A. 8 is given to us. We don't know T. Okay, now we can solve. This is equals to 0. This and this is 0. 2 here 1, 2 here 4. That is plus 4 multiplied by t. So this will give us 4t square. There's square here. This 500, 500. What I'm going to do, I divide both sides by 4. So this and this will cancel. It means, therefore, here 1, here 265. 625 equals to t squared. So to get t now, we find the square root of 625. You agree with me? That is 25. You can't leave it like this. Time. What is the unit? Is it meter? Is it seconds? Is it hour? Go back to the question. So you can see seconds. 25 seconds. Hope you understand this. Thank you for viewing. Let's look at this. It says, a particle starts from rest and moves with a uniform acceleration of 4 meters per second squared. What is its velocity after covering a distance of 8 meters? Let's assign our symbols. A particle starts from rest, that is u equal to 0. Rest, initial velocity. At this what? Acceleration. A. What is the velocity after covering a distance? That is v, final velocity. And this is given to us s. Remember the 3 important equation of motions, which says the final velocity is equals to initial at. So distance equals to ut plus 1 over 2 at squared. V squared equals to u squared plus 2as. Please note that if you have this at the back of your mind, you don't need to write them. I'm writing this for the purpose of this class. I don't want to bring out an equation. You are asking me, why this equation? The reason why I'm writing them out. For you, you don't need. If you have them at the back of your mind, simply start asking yourself, among these, which of them fulfill this question? Let's check. For u, u is in all of them, okay? For a is in all of them. For v, v is in only 2, only these 2. I mean, this is already out. Among the remaining 2, which one has s? It's only this one that has x. So the last one will be used, which says v squared equals to u squared plus 2as. Okay, now let's start. Our v is the question. We are looking for v. U is given from rest, 0 square. 2. A is given 4. S in meter. Remember, meter per seconds. This is meter. No need to change. Put 8. That's all. Now, this is equals to, this already 0. This and this will give us 8. 8 times 8 is 64. V is equal to the square root of 64. V is equals to 8. It means, therefore, we have this meter per second. Don't forget to put the unit. Very important. Very important. Hope you understand this. Thank you for viewing. Let's look at this. It says, a body which is uniformly retarded comes to rest in 5 seconds. Remember, the body could be a car, a plane, a person, a stone. It could be anything. Body is body. Uniformly retarded, that is negative a. Remember, we use a to represent both acceleration and deceleration. It's just that deceleration is minus. Comes to rest in 5 seconds. Whenever you see rest, it's talking about the velocity is equal to 0. So when it comes to rest, that is the final velocity, is equal to 0. Came to rest. Starting from rest, that is initial velocity equals to 0. Came to rest, final velocity equals to 0. After traveling a distance of 10 meters, distance is given, which is s. What is the initial velocity? U. Now remember the three important equations of motions. We said V is equals to U plus AT equals to UT plus 1 over 2 AT squared. Why B squared equals to U squared plus 2AS. Remember this? Now you ask yourself. We have A in all of them. We can't cancel any of them. We have V here. We don't have V here. This is the culprit. We can't use U. We don't have V. Okay, let's continue. T is here, but T is not here. Hold on. Don't cancel yet. It has V, It has U, Has A. Okay, you continue. S is here, but S is not here. You see? As you can see, T is here, but T is not here. S is here, S is not here. Okay? U is here, U is here. You see? What this one has, this one does not have. What this one has, this one does not have. It means at the end of the day, you are going to use the two formulas or the two equations. Use two of them to complement themselves. How? Let's start with the first one. The first one, final velocity, 0. Initial velocity, that's what we are looking for. Acceleration, we don't know. That is deceleration, it's not known. What about the time? 5 seconds multiplied by 5. No problem. Let's go for the second one. D, 0. U, we don't know. 2, okay. A, okay. We don't see no. S, distance, 10 meters. We have to use two of them now, okay? So let's continue with this. As you can see, 0 equals to U squared plus 20A. Why this is 0 equals to U plus 5A. What are we looking for? We are looking for U. So therefore, A should go. From this second one, or the first one, any one, let's solve for A. So I'm going to call this one equation 1, call this one equation 2. So from 2, you agree with me, A, we move this here to have minus 5A, divide both sides by 5. You agree with me, A therefore is equals minus U over 5. Okay? Good. Now that we have this guy A, we can substitute this here in the first equation to get U. So therefore 0 is equals to U squared plus 20 multiplied by minus U over 5. If we solve this now, you're going to have U squared plus this one, this is 4. That is minus 4U, which is U squared minus 4U. Now what is common between these two is U. U minus 4. Divide both sides by U. This cancel this. That is 0 still. We can say 0 therefore is equals to U minus 4. To move this to this side, U therefore is equals to 4. Forward 4 meters per second. This is the answer. This is the reason why you should watch all my videos, because in each video I drop new thing. I drop new strategy. You can approach this one in another way. But for me, the best way I think is look at the formulas. Eliminate the one that is least possible to be used. Follow the other ones. Hope this is understood. Thank you for viewing. Now, let's look at this. It says a body moving with uniform acceleration has 2 points, this and this, on the velocity time graph of its motion. Calculate A, the acceleration. Now, the first thing you need to do when you see this kind of question is to draw the graph. Let's do that. I'm going to take a line from here, another line, okay? Then we take some values, rough values, okay? You agree with me? This is the velocity line. This is the what? The time line. And this has no unit. We are going to assume it is in the default unit. Here is meter by seconds, while here is in seconds. Okay? Now, whenever you see anything like this, it's always the x-axis before the y-axis. The x horizontal versus the vertical. Because the ground must be there before you stand upon the ground. This must be available before you stand. So S must be available before you stand. So for the S, 5, let's say it's somewhere here. For this other one, this is S. Let's say somewhere here. 20. We go back 15, let's say somewhere here. 60, let's say somewhere here. Okay? Now, we are going to plot. I'm going to plot this. Plot it here. Plot this. Let's assume this as straight lines. Plot it here, okay? Now, we draw a straight line from these two coordinates. Okay? Now, the question says, calculate the acceleration. Remember, acceleration is velocity over time. Let's take rough line again. From here, this is red to here, okay? Red. From here to here, you agree with me, is 20 minus 5, which will give us 15. So this is 15. Here to here, that is 60 minus 15, which is 45. Are you agree with me? Acceleration is velocity. You transfer this line here, velocity, over time, This one, change the time, 15. Our acceleration is equals to 45 over 15. 3 equals to 3 meters per second square. That is our acceleration A. Hope you understand this. Change in velocity over change in time. This is change in velocity, change in time, coordinates or points. All this is understood. Thank you for viewing. Let's look at this. A car starts from rest at a checkpoint A. From rest, okay? And comes to rest at the next checkpoint B. 6 kilometers away. General information. General info. In just 3 minutes, okay? It has first a uniform acceleration, then a constant speed, and brought to rest in a uniform retardation. Sketch a velocity time graph of the motion. With all this information, you can do that. Let's start. First of all, we're going to get this, then we get this. Start from rest, A, point A. This is point A, from rest. That is 0. Okay? And comes to rest at point B. So, this is our point B. We don't know what is here. Remember, this is V in meter per seconds. This is our time in seconds. That is the axis. Okay? Now, we are told between here and here is 3 minutes. To cover this, 3 minutes. 3 minutes into seconds, because this is seconds, is 3 times 60, which will give us 180. It means at this point, this is 180 seconds here. This is 0 seconds. We are still going. Everything you see here now is 6 kilometers. But for this velocity time graph, there is no way to represent distance. We leave it inside the question. We don't need to bring it out. At first, there was acceleration for 40 seconds. So let's say somewhere here is 40 seconds, okay? Because this is timeline. It accelerated up. We're going to say it accelerated up. We're not given the velocity. So we are just going to assume it's somewhere here. Okay? Then there was a call start speed. Call start speed. Brought to rest again. That is coming down to rest. Coming down to rest. Okay? It's brought to rest in 20 seconds. Okay? Brought to rest, came down in 20 seconds. But the issue now is that, how do we assign this 20? Let me show you. Brought to rest. That is, why? You understand what we are talking about? This is your speedometer. Assume you are driving, for instance. You start from 0, that is starting from rest. This means from rest. You speed up. As you are speeding up, you get to 60, for instance. This means you go to 60. This is 60. You go to 60, and how many seconds? Let's say 3 seconds. When you get to 60, you say, I don't want to speed again. I don't want to speed again. This 60 this speedometer I'm seeing, I don't want to increase my speed. You remain there. Time is going. You are driving at 60 kilometers per hour, for instance. You are just driving. That means you are maintaining this 60 now. You are not increasing it. This is maintenance. You are maintaining it. Constant. At a point, you remember, I need to buy something in KFC, one of the restaurants. You start slowing down. That means your speed now, that was going up before, that came here, you are now decelerating. You are coming back because you want to stop now. You need to apply your brake. You are not coming down. You are decelerating. This is deceleration. Coming back to 0. This line of 0. That is what we are talking about. Okay? So, maintain. Came down. Now, it came down within 20 seconds. That means, while it was here, from here to here, it came down. So now, I want to get this. So it means between here and here is 20 seconds. So if this is 180, 20 seconds backward from 180 is 160. That means here is 160. These are the things this question wants to see. If you can reason out, if you can think out. 160. Remember here, this one alone has mark of its own for you to be able to draw this out. It has its own mark. Okay? Now, the next thing we need to do now is to start calculating maximum speed. If you apply all the 3 formulas, say V is equals to U plus AT, S equals to UT plus 1 over 2 AT square, V square equals to U square plus 2AS. If you apply all of them, for this first one, if you are looking for this is 0 anyway because from rest. What is A? We don't know. What is T? We know. 40 because we are looking information within this location. The speed. This is the maximum speed here. So we can use this if we had information about the acceleration. Here, the same thing, acceleration. It means none of this will help you. What do you do now? Start crying? No, calm down. This question want to test you to see if you remember that the total distance covered is equal to the area of this trapezium. This is a trapezium. Okay? The total distance cover, total distance is equal to the area of this, the trapezium. Okay? Now, what is the total distance? Total distance is 6 kilometers. 6 kilometers. Area of trapezium is 1/2. Remember? This to this, let's call this one CD. Okay? CD, here to here, plus AB. Multiply by the speed. I put V or whatever, let's put S. Cap letter S. Now, you calculate. This is equals to 1/2. What is CD? That is 160 minus 40, which is 120. Plus AB, here to here, that is plus 180. We are looking for this. This is in kilometer. We remove the K, replace with 3 zeros. So now, we are going to look for S. This multiplied by this, that is 6 multiplied by this equals to this plus this will give us 300. We divide both sides by 300. This and this will cancel. It means this will cancel. We have 20 here. It means our S is equals to 20 multiplied by 2, which is 40 meters per second. Okay? Now that we have this, say we should calculate the retardation. Because we now know this place now to be 40 meters per second, that is, we know this location to be 40 meters per second. We already have the unit here. No need to put it here. That means here, our initial velocity is 40. Our final velocity at rest is 0. Okay? So, to get the acceleration now, you will agree with me, this is V minus U over T. This is the final velocity. Our final, when it came to rest, remember, when it comes to rest is 0. That is final 0. Okay? The beginning of coming to rest is 40. This is the beginning while it was about coming to rest. That is initial for the deceleration. That is 40. In how many seconds? 20. It means, therefore, it's minus 40 over 20, which is minus 2 in meter per second square. Okay? Please, you also know that you can also put this as meter seconds raised to power minus 1 indices, meter seconds raised to power minus 2 indices. Hope this is understood. Thank you for viewing. Let's look at this. It says a car starts from rest and moves with a uniform acceleration of 10 meters per second squared. For 10 seconds, the distance it covers in the last 1 second of its motion is what? Remember, this kind of question now is testing your ability of understanding that if this is the velocity time graph, that you should remember that this is the acceleration side. It's accelerate. That is the only information given to us. Remember, it start from rest simply means start from 0. The initial velocity is equal to 0. This is where it stops. That is the final velocity. Let's say somewhere here. We don't know. the value. This is our u equal to 0. Remember, the acceleration is 10 meters per second squared. Okay? How many seconds? This happened from here to somewhere here for 10 seconds. From this point to this point. Now, the question says, what was the distance it covered? We can't represent distance here. Just distance? No. Last 1 second of its journey. Last 1 second. This is the one we are aware. 10 seconds. For the last seconds, don't say it's 9. No. Don't say it's 9. No. We are always connecting it to the beginning of the journey. Always connect everything to the beginning. We are going to do from beginning to 9 seconds. From beginning to 10 seconds. What are we doing? We are going to do the distance it covers. Start. From beginning to 10 seconds, this is the distance it covers. Let's say the distance is whatever, let's say 50 meters, for instance. Before it gets here, while it was 9 seconds, it covered, let's say, 40 meters. We are interested in the differential. That is 50 minus 40, which is 10. That is how to calculate it. Why? We must connect it back to the source. Why are we interested in the source? Because of this u, that is 0. So now the next thing we are going to check now is what are the parameters given to us? The parameters given to us here, a is given, acceleration is given to us, start from rest is given, u is given to us, distance is asked, time is mentioned. Among the formulas, v equals to u plus at equals to ut plus 1 over 2 at squared. V squared equals to u squared plus 2 as. Which one do you think covers these parameters? As you can see, v final velocity is here. Although it's not mentioned here, we know because once you start running, anywhere you get to as you accelerate it, it's your final velocity. Okay? So this here, so if this here, we are going to go by this first two. You that don't have v at all, you are out. U is here. Initial. A is here. Very good. Distance is here. Distance is not here. And we are told to look for the distance. Remember, distance supposed to be s, that is small letter x, as far as these formulas are concerned. So this one does not have distance at all. Okay? Time is mentioned. This one does not have time, but this one has time. It means, therefore, we are going to use two of them. Okay? So, therefore, I'm going to teach you another method of getting it straight. Let's follow this method. Therefore, B, for this first one, I'm going to say V, initial is 0 plus. A is what? A is acceleration, which is 10, multiplied by the time, which is 10 seconds. So, V, therefore, is 100 meters per second. Okay? We are not looking for V. We are looking for what? We are looking for S. That is the distance. So we're going to substitute here now. We have V now to substitute here. That is 100 raised to power 2 equal to U is 0, 0 square plus 2A. A is 10. We are looking for X at, first of all, 10 seconds. So therefore, this is what? 100 square equals to 20s. Okay? You agree with me that this will give us divide by 20 equals to the distance. This cancel this. 1,000. This is what? 500. It means, therefore, our S is 500 in meter for now at 10 seconds. 9 seconds, we do that again. As you can see, for the first one again, we're going to do for V. This already 0 plus 10 meter per second square multiplied by 9. So V is equals to 90. Okay? Therefore, the second one, we put 90 here. We put square equals to 0 square plus 2 multiplied by 10 multiplied by S. So now we have 90 square equals to 20S. That is 90 multiplied by 90 over 20 equals to this. This cancel this. This here 1, this here is 45. 45 times 9 is 405. This one is at 9 seconds. Remember, we use 9 here for the time. Here, we use 10 seconds. So, distance at 10 seconds minus distance at 9 seconds. So, we say the distance now we are looking for, which is the last 1 second, is 500 minus 405, which is equals to 95 in meter. Let's look at this question. As you can see in this place, a body which is uniformly retarded comes to rest in 5 seconds after traveling a distance of 10 minutes. What is its initial velocity? Depends on the information given to us here. First of all, draw the diagram. Let's draw a rough diagram. Say this is the velocity line. This is what? The time axis. Okay? Meter per seconds. And this is in seconds. Okay? Now, a body which is uniformly retarded, that is going down, that is the first message we are getting. So you start from there. So from here now, when you hear retardation, you come to this point and take it down. That is all. Then, we don't know the V here. That is the initial velocity. We don't know. That is, when it started retarding, what was the velocity it started from? Okay? From here to here, we are told is 5 seconds. Okay? But the distance covered here, remember, distance is equal to the area under consideration. Is what? 10 meters. We are asked to find this, the starting point of this deceleration. To do this, very easy. Is the area of this equals to distance. Okay? So, distance is equals to area of the triangle. Okay? Now, what is the distance? Is 10. What is the area of the triangle? Is our base multiplied by height, which is this initial velocity for the retardation. You agree with me that this is 5u over 2. We cross multiply, we have 20 equals to 5u. Divide both side by 5. U therefore is equals to 4 meters per second. Hope you understand this. Thank you for viewing. Let's look at this. It says an object falls freely from a height of 25 meters onto the roof of a building 5 meters high. Calculate the velocity with which the object strikes the roof. Okay? Now, let's assign symbols. As you can see, let's first of all draw the diagram. Let's assume that this is the height, okay, where it was falling from. This is the ground level. Say this is the house. So from here to here is 25 meters. From here to the top of the roof, you know that the height of the roof is 5 meters. It means from here to here is 20 meters. Because here is 25, here is 5. So 5 minus this remaining one from here to the top of the roof. See, this is the top of the roof. Okay? It means we know the distance now. Now, we know the distance. We are asked to find V, the final velocity. The initial velocity, remember, if you hold something like this, you release it. While you are holding it, the velocity is 0. It means the initial velocity is 0. So therefore, initial is 0. We are looking for this. Now, among the 3 equations of motions, which of them fulfills this question? I don't want to write everything. If you check very well, you discover that it's v squared equals to u squared plus 2as. But we are not going to do it like this now. We are going to put g here because now we are talking about falling. So falling is g instead of a. They are all acceleration, but because it depends on gravity, we put g here. This still remains small letter s for distance. So what is g? G is acceleration due to gravity. Acceleration due to gravity is always 10 meters per second square. Okay? Now let's substitute here. We don't know v, that's what we are looking for, the final velocity. We know this to be 0 plus 2g. What is g? G is 10. That is multiplied by 10, multiplied by s. That is, the distance from here to here is 20. Okay? Then, if you work on this, you agree with me, you're going to have this multiplied by this is 400. So v is equal to the square root of 400. So what is the square root of 400? You agree with me, it's 20. So v therefore is 20 meters per second. That is the final velocity. All this understood? Thank you for viewing. Let's look at it. It says a boy cycles continuously through a distance of 1 kilometer in 5 minutes. Calculate his average speed. Okay? Average speed is equal to the total distance over the total time, which you can say distance over time. So from this question, what is the distance? You agree with me? The distance in this question is 1 kilometer. All over. The time is 5 minutes. We cannot use minute a kilometer. Kilometer. Because you agree that the unit of speed is meter per seconds. So therefore, everything here should be in meter, while this should be in seconds. So for this upper one, we're going to remove this k, which is 1000, to replace k, so that meter can be here to match this. All over 5 multiplied by 60. We are converting these minutes to seconds. So this is second. This cancel this. This here 1. This here is 20. 2 here is 10. 2 here is 3. It means 10 over 3 meter per seconds. This is what? 3.33 meter per seconds. So that is what? Our average speed. Hope you understand this. Thank you for viewing. Let's look at this. It says a car travels with a constant velocity of 45 kilometers per hour for 20 seconds. Constant velocity. If I were you, I will start drawing the diagram. That is the velocity time graph. Velocity, meter per seconds, time in seconds. Constant. The beginning, what we are told. We know it should be like this. We know, okay? But this information did not give us those constant. That is the starting point from this question. That is what we are told. We are not interested in where it was coming from. Unfortunately, this is in meter per seconds, but this one is in kilometer per hour. So I will just put this one in kilometer per hour according to the question, okay? I will just still leave this one in seconds. It doesn't matter. You can do it like that. But while you are calculating, you do the conversion. This is just to get a picture from this question. Okay? This journey was for 20 seconds. So here is 20 seconds. Okay? What distance does it cover in this time? So remember, the distance cover is always the area of whatever we are considering, the area under consideration. So this is the constant velocity is stop here. So the area under this. I want to ask you, what area are you seeing here? This is the area of a rectangle. So the area of a rectangle is equal to the distance it covers. So therefore, distance is equal to the area of this rectangle. Okay? So therefore, we come here to say the distance is what we are looking for. The area of this is whatever that is here multiplied by this. That is 45 kilometers per hour multiplied by 20 seconds. We are going to convert this to meter per seconds because we know that we are looking for question in meters. Unless if it's an option, you see kilometer in the options, then you put it in kilometer, okay? So it depends on what you want to do. If you want to convert to kilometer, better turn this seconds to hour. But I will do in meter per second. That is the standard of speed. So this one, as you can see, is 45 kilometer over hour. That is the meaning of this, kilometer over hour. 20 seconds. Okay, now, say 45 multiplied by, we replace this 1000 over, we replace it with 60 times 60. That is, this removes so that only m will remain. Here, we are converting hour to seconds. So remember, we still have 20 seconds. This and this will cancel so that only m will remain. So what you can do generally now, you can simply say 45 times 1000 times 20, this 20 over 60 times 60. So everything will be in meter because this and this cancel. So distance is equal to this. So it just cancel. 3 here 15, 3 here is 2, 3 here is 2, 3 here is 5. Okay, 2 here 1, cancel this 2, 2 here 1, 2 into this is 50. Okay, it means therefore distance is equals to 5 multiplied by 50. This is 250 in meter as per the distance we are looking for. Hope you understand this. Thank you for viewing. Let's look at it. It says a body starts from rest and accelerates uniformly at 5 meters per second square until it attains a velocity of 25 meters per second. Calculate the time taken to attain this velocity. Draw the diagram. Draw the diagram. Let the diagram help you. Velocity time graph. This is velocity line. And this is the time axis. Acceleration. Acceleration. Just rough diagram. Until it gets to a point when it attains the velocity of 25 meters per second. Okay? But the acceleration was 5 meters per second squared. Okay? Calculate the time taken to attain this velocity. We need this position, the time. We don't know. We don't have information about the time. What do? As you can see, this information is captured here. The next thing you have to ask yourself, what is the initial velocity? Start from rest. It means the initial velocity u is equal to 0. The final velocity v is equal to this. This is the time. This is the acceleration. Among the 3 important formulas of motion, which of them does this describe? If you cannot recall, you write them down. Say the first one is v equals to u plus at. Second one is speed equals to ut plus 1 over 2 at squared. This is v squared equals to u squared plus 2as. Okay, so among these, which is described, let's see. Velocity, we have it here. All of them have v? No. It's only this guy and this guy that has v. So this is already out. Let's continue. U has u, it has u. A, it has a, it has a. T, it has t, no t. You are out. So the first one, that is v equals to u plus at. Now let's see. This is 25. This is 0 plus 5 multiplied by t we are looking for. That is 25 equals to 5t. Divide both sides by 5. 5 cancel 5. 5 here, you have 5. So t therefore is equals to 5. Okay? This is in seconds. Once you identify the formula to use, that is equation, the rest is just arithmetic. Okay? Let's look at this question. It says a train has initial velocity of what? 44 meters per second. So u is equals to 44 meters per second. Okay? And an acceleration of minus 4 meters per second squared. That is a is equals to minus 4 meters per second squared. With this, we know they are talking of what? Deceleration. That is retardation. Because this is minus. It means the speed it started slowing down. Now, we need to know the final velocity. The time is given as 10 seconds. Among the 3 equations of motions, which one fulfills this? As you can see, there is no distance here. 2 of the formulas have distance. We are going to go with the one without distance, which says v is equals to u plus at. This is the one that don't have distance, because here there's nothing like distance. So we substitute here. V we are looking for, u is 44, plus a is minus 4, y time is 10. That is 44 minus 40, that is 4 meters per second. This is the final answer. Hope you understand this. Thank you for viewing. Let's look at this question. It says, if a car starts from rest and moves with a uniform acceleration of 10 meters per second square for 10 seconds, the distance it covers in the last 1 second of motion is what? Okay? Assume this is the distance. This is the starting point. From here to here is, say, the distance it covers for the past 10 seconds. You agree with me somewhere here, let's say it's for the 9 seconds. This is what we are talking about, this distance. But one thing you must do in a question like this, always connect them to the beginning. The beginning, because the beginning will give us initial velocity. If you jump and walk here, you make issue for yourself. Now, the next thing you should ask yourself, among the 3 equations of motion, which one do you think fulfill what is being described here? You agree with me, the first one does not have distance. That is, v equals to u plus at. So this is already out of it because we are looking at distance here. The last one has distance, but it has no time. We can't use it. So the middle one it has distance, it has time, it has initial velocity. So this is the one we are going to use. But the point is, we are going to put this 10 seconds and 9 seconds into consideration. That is the distance that happened between 9 seconds and 10 seconds. Okay? Now for this question, first of all, let's say the first distance we are going to look at is the distance at 10 seconds is equals to the initial velocity, which is, it start from rest. It means the initial velocity is 0. Okay? So we're going to put 0 here, multiply by t, which is 10. Okay? Because when time is equals to 10, that's what we are considering now. Okay? Plus 1 over 2 multiplied by a, which is this, multiplied by 10 raised to power 2. That is the time. This is already 0 plus, here is 5. 5 times 100, you agree with me, is 500 in meter. Okay? When the time was just 10. For distance when time is 10. So now, when time was 9 seconds, we're going to do the same thing. Again, this is automatically going to be 0. No need to waste our time. Multiply by, this time, acceleration still remains the same. Multiply by 9 squared. So this is 5 times 81. You agree with me, this is 405 in meter. So to get the distance that happened in the last seconds, we say the distance we are looking for is equals to the distance at 10 minus distance at 9, which is 500 minus 405. You agree with me, this is what? This is equals to 95 meter. This is the answer. Okay? Hope you understand this. Thank you for viewing. Now, let's look at this. It says, a body starts from rest and moves with a uniform acceleration of 6 meters per second square. What distance does it cover in the 3rd seconds? The distance it covered in the 3rd seconds. Let's see. Let's draw the velocity time graph. It starts from rest, going. It was running at a uniform velocity of 6 meters per second square. So 6 meters per second square. Now, let's say that this is the 3rd, say this is the 3rd seconds. So the distance is always the area under consideration. You can't do that here because it says 3rd seconds. That is from second to 3rd. So therefore, you have to recognize that what? Before this, let's say here it was 2. Say here was 1. So we are looking at the distance that happened somewhere here. So we are going to take this one up again. So this area is what is asking us to find. How do you get that area? To get that area, you get the total area minus this area. You get the total area minus this area. What area is this? This is a triangle which says half base times height. What is the height? We need to bring it here, height. This one must have height. How do you get this line? This is velocity line, this is time line. To get velocity corresponding to 2 seconds, we multiply by that is velocity equals to at, which is acceleration multiplied by time, 2, which is 12. So here is 12. The first one for 3 is 6 multiplied by 3, which is 18. Here is 18. Okay? Now, we know the first height is 18. This is 3. Okay? Why the second one, you agree with me, is simply 12 and 2. So here we do 1 over 2 base times height. That is 27. Why this is 1 over 2 times height, which is 12. This minus this, that is 27 minus 12. You agree with me, you're going to get 1.5 in meter. So this is what we are looking for. Some students will rush and calculate just 3. It didn't say in 3 seconds, third seconds. Third is different from 3. Hope this understood. Thank you for viewing. Let's look at this. It says a body accelerates uniformly from rest at the rate of 3 meters per second square for 8 seconds. Assign the symbols. First, from rest, it means u is equal to 0. Let me use another color. U is equal to 0. At this rate, this is A, this is T. Calculate the distance, that is small letter s, covered by the body during the acceleration. Draw the diagram. Draw the diagram. Don't forget that. To draw the diagram, that is the velocity time graph, you agree with me, from rest means starting from rest. Okay? And this is 3 meters per second square for 8 seconds. Okay? This is a u. U equals to 0. We want to calculate the distance during the acceleration. This is the distance during the acceleration. That is the area under consideration. This is acceleration. How do you get this area? This is a triangle. You can check very well. This is a triangle. And the area of a triangle is half base times height. What is the base here? Is 8. From here to here is 8. What of the height? Height is the velocity. To get the velocity, you have to say velocity equals to acceleration times time, because acceleration is velocity over time. Okay? You cross multiply to get this. Okay? Now, what is acceleration? Acceleration is 3 and the time is 8. Okay? That is, we are talking about 24. So therefore, this is equals to 1 over 2 multiplied by 8 times 24. 1 here, this is 4. 4 multiplied by 24 to get the distance. You agree with me that this is 96 in meter. So this is the distance we are looking for that happened under this acceleration. Very easy, not difficult. 2 things. This diagram is a savior. Don't forget, from rest, u equals to 0. Also remember that area, under consideration, represent the distance. Hope this is understood. Thank you for viewing. Let's look at this. A particle starts from rest and moves with a constant acceleration of 0.5 meters per second square. Calculate the time taken by the particle to cover a distance of 25 meters. Okay? Again, learn to draw out the diagram. From rest mean from rest. Okay? From rest. And move with a constant acceleration of this. Constant or also uniform are the same. So this is the acceleration, 0.5 meter per second square. Okay? Calculate the time taken by the particle to cover a distance of 25 meters. So it means at this point, it accelerated from here to here. The area under this is talking about what? The distance. And we are given that the distance here is 25 meters, according to this. Okay? But we are asked to calculate t. What is this? This is simply a triangle. Okay? We know the area to be 25 as per the distance meter. Okay? Now, we need the height. We need this. We don't know this, but we can calculate for this height. How do you calculate for this height? That is corresponding to this v. If you have been watching my video on this, it's the same thing. To get v, we use the acceleration. That is, to get v, we say at. What is a? A is 0.5. But we don't know t. We simply put here 0.5 t. Okay? So how do we get this area now? The distance we already know is equals to the area under consideration. That is half base times height multiplied by 0.5 t. We already know this to be 25. 1/2 times 0.5. T multiplied by t is t squared. Okay? We cross multiply. This will give us 50 equals to 0.5 t squared. We divide both sides by 0.5. This cancel this. You agree with me? This is t. This will give us 500/5, which is, as you can see, is 100. This is square. Then t is equal to the square root of 100. You agree with me? That is 10. So the time we are looking for is 10 seconds. Hope this is understood. The idea here is just know that the area under consideration is equal to the distance. Then you should be able to know the height using the acceleration information. Once you do that, this is just arithmetic. Okay? Let's look at this. How far will a body move in 4 seconds? How far will you move in 4 seconds? If uniformly accelerated from rest at the rate of 2 meters per second square. Uniformly accelerated from rest. From rest is giving you a good information that u is equal to 0. Okay? Good. Now, the rate is given to us. This our A. We have the t. How far means what? The distance. Small letter s. Therefore, which of the formula will you use to solve this? You can also draw the velocity time graph that says uniformly from rest. Acceleration is 2 meters per second square. Time is given as 4 seconds. Okay? The distance we are talking about is inside here. That is the area, or that is, we don't know the final velocity. But we know the initial velocity to be equal to 0. We are looking for this area, for the distance. You can also use this because now distance is involved. If you don't want to use this, you can also use distance equals to ut plus 1/2 at squared. We are looking for distance. We know the initial is 0. We know the time. We know the acceleration. We know the time. Now, let's see. If we use this, we say s is equals to 0 multiplied by t, which is 4, plus 1 over 2. Acceleration is 2 multiplied by 4 square. This cancel this. This is 0. This will give us 16. So the distance we are looking for is what? Is 16 meter. If it was this one we use, we say the area under consideration is our distance. What is this? This diagram is a typical triangle. What is the area of a triangle? Half base times height. Half of the base times height. What is the base? You agree with me, the base here is 4. Here to here is 4. What is the height? We don't know the height. That is V. We can get the V from this information. V is equals to 80, which is equals to acceleration 2 multiplied by the time 4, which is 8. We can substitute that here, 8. Half base times height is actually equals to, here 1, here 2. This time this is 16. Still in meter. Are they not the same? So either you use this or you use this, you are good to go. Okay? All this understood. Thank you for viewing. Let's look at this. It says, a car takes off from rest and covers a distance of 80 meters on a straight road in 10 seconds. Calculate the magnitude of its acceleration. The magnitude of its acceleration. Let's bring out the information. From rest. From rest means u is equals to 0. That is from rest. Started from 0. I cover a distance. This is our x. Let me use different color. This is u equals to 0. This is our s, small letter s for distance. This is the time t. Calculate the magnitude of the acceleration. Okay, so let's use the velocity time graph. It accelerated from rest, and the acceleration is what we are looking for. The distance is covered. Under this, the distance is the area under consideration. It is 80 meters. Okay? This happens for 10 seconds. Okay? The final velocity should be here. To get it, we have to say V is equals to 80, which is A we are looking for. We don't know A, but we know T as 10. 10E. So here is equals to 10E. 10E. So now, if you bring this information together, what is the area of this? A triangle. Half base times height. Half of the base times the height. This is the base 10. The height is 10e. Okay, that is half of the base times height, 10e, is equal to the area, which is the distance as 80. That is all. If you solve this now, you agree with me, here is 1, here is 5. This is 50a equals to 80. Divide both sides by 50. This and this will cancel. A therefore is equals to, this will give us 1.6 in meter per second squared using the area. If you didn't want to use this, you can use other methods, especially this formula that says this ut plus 1 over 2at squared. We know the distance to be 80. This is the distance. The initial is 0. The time is 10. 1 over 2. We don't know a. We know t to be 10 squared. 1 over 2a times 100. That is, here 1, here 5. That is 15a. If you multiply this, is 15a. 80. Divide both sides by 50. A therefore is 80 over 50. As you can see in this place, this cancel this. Again, you're going to have 1.6 meter per second squared, just as we saw with this. So this and this are actually the same. Hope this understood. Thank you for viewing. Let's look at this. It says a bus traveling at 15 meters per second accelerates uniformly at 4 meters per second square. What is the distance covered in 10 seconds? You need to understand this question very well. As you can see, there is nothing like from rest, initial velocity. It means we are going to use this as our initial velocity. What it means is that if we draw this like this, somewhere here, let's put 15 here in meter per second for this velocity axis. So it means it was like this. Now accelerating. It was traveling this, now accelerating at 4 meters per second square. Okay? If I take this up further, you agree with me now? We need to now know the final velocity. This is our initial velocity. Okay? This area is the distance covered. Okay? That is what the question is asking us to get. Can use two methods. Either we use the strategy of the area, or we use this formula that says S is equals to UT plus 1 over 2 AT square. Okay? We are looking for S. Initial velocity is 15. Multiplied by T. We know our T is 10. That is this. Plus 1 over 2. A is given to us as what? As 4. Multiplied by T. That is 10 raised to the power 2. Okay? This is 150 plus 1, 2. This is 100. That is 200. You agree with me? We have 350 here. 350 meter. So our distance is 350 meters. Okay? So this question want to test the way we think. Let's look at this. It says a body starts from rest and accelerated uniformly at 5 meters per second square. From rest again means u is equals to 0. Okay? And this is our A. Calculate the time taking t by the body to cover a distance of d, that is small letter s. Without being told, you agree with me that the formula we're going to use, if you have been following me, is this 1 over 2 AT square. Okay? So we know the distance to be 1 kilometer, which is 1,000 meters here. It's equals to the initial velocity, 0. Multiply by the time taken. We don't know the time taken. We know the acceleration to be 5. The time taken we don't still know, okay? So 1,000 now is equal to 0 plus, this is 5t square over 2, which you can say is 1,000 equals to 5t square over 2. You cross multiply to have 2,000 equals to 5t square. You divide both sides by 5. 5 cancel 5 here. You agree with me, 5 here. This is 400. That is 400 equals to t square. T, therefore, the square root of 400. And you agree with me, that is 20. Okay? So time taken is 20 seconds. If you have been following me, you know that we have covered things like this. All this understood. Thank you for viewing. Let's look at this. It says a particle starts from rest. That is from rest. It means the initial velocity is 0 and moves a constant acceleration of this. That is, this is our A. The distance cover, that is small letter s cover, in 10 seconds. We're going to use this formula that says s equals to ut plus 1 over 2 AT square. Why are we using this formula without the other? Because in my memory, I already scanned the 3 equations, and I found that this is the most suitable. Because here we have the distance we are looking for as a parameter. The initial velocity is 0. The time we are talking about is 10 seconds. 1 over 2 multiplied by A. What is A? Our A is the acceleration, which is 0.5 multiplied by 10 raised to the power 2. This equals to 0 plus 1 over 2 times 0.5 times 100, okay? This is equals to 1 over 2 times, this will give us 50. Here 1, here 25. It means therefore our distance is 25 meters. Hope you understand this. Thank you for viewing. Let's look at this. It says, the diagram below illustrates the velocity time graph of the motion of a body. Calculate acceleration of the body in section OP here. But the total distance is 195 meters. Total distance. When we say total distance, what is that? That is actually equal to the area of this trapezium. So we are first of all going to use that information. That is, the area of the trapezium is actually equal to the total distance. That is 195 is equal to 1 over 2 area of a trapezium is this length here to here, which is here to here. What is here to here? Is 11 minus 6, which is 5, plus here to here, which is 21. Multiply by this height. This height is V here. We don't know V. So first of all, let's get V. Once we get V, we can get the acceleration. Now, this is equals to 1 over 2. This is 26. This is 13V, 195. Divide both sides by 13. V therefore is equals to 195 over 13. And you agree with me, if you divide this, you're going to have 15. It means our final velocity here is 15 meters per second. Once we have that, we can get the acceleration. Acceleration is equals to velocity over time. We have velocity to be 15. The time here in this section, the time is 6. Put the 6 here. You agree with me, if you divide this, you're going to have 2.5. So therefore, our acceleration is equals to 2.5 meters per second square. Okay? So that is our answer. Hope this understood. Thank you for viewing. Let's look at this. It says, the diagram below illustrates the velocity time graph of the motion of a body. Calculate the total distance covered by the body. As you can see, this information, you remember, distance covered is actually equal to the area of this figure. Okay? So what we're going to do now is to get the area of this. How do we calculate the area? The area of this is actually the area of A plus the area of B plus the area of C. Area of A, this is a trapezium. Here to here is 10. Here to here is 20. Here to here is 5. So to get this area, I'll say 1 over 2. This plus this multiplied by this. That's 1 over 2. This is 35. 2 here 1, 2 here 15. That is 15 times 5, which is 75. So we have this area. This one, you agree with me, we are looking at a rent angle. Here to here is 10 minus 5, which is 5. Here to here is 20. So is this multiplied by this, that is 5 multiplied by 20, which is 100. Then we do for this, that is a triangle. This is 20. Here to here, that is 15 minus 10. So this will give us 5. 15 minus 10 is 5. So it's half base times height, which is 10 multiplied by 5, 50. We had everything together. So the distance is equals to 75 plus 100 plus 50. You agree with me? This plus this is 150 plus this is 225. That is 225 in meters. Hope you understand this. Thank you for viewing. Let's look at this. It says The figure below shows the velocity time graph of a car which starts from rest. That is, the initial velocity u is equal to 0, okay? And is accelerated uniformly at the rate of 3 meters per second square. 3 meters per second square, okay? For 5 seconds, 5 seconds, okay? It attains a velocity which is maintained by 1 minute. So this velocity it attained here, okay, was maintained for 1 minute. That is, from here to here, it maintained the velocity for 1 minute. If you add 1 minute to these 5 seconds, you agree with me, is 65. That is, 5 plus 60. 1 minute is 60 seconds. That is 65. 65 seconds. Okay? The car is then brought to rest by a uniform retardation after another 3 seconds. So we have 3 seconds to this, that is 68 here. This is the retardation. Okay? You don't need to put all those SS, which is second, because S is actually already here. Okay? So calculate the total distance covered. Total distance covered. One thing I keep telling you, if you have been following me, is the distance covered is actually the area of this figure. This is a trapezium. And you agree with me, from here to here is 65, from here to here is 5. To get from here to here is 65 minus 5, which is 60. Here to here, okay? Then here to here is what? 68. What about the height? We need the height, this location. We don't know the information, but we have the acceleration. To get the velocity is actually 80 because acceleration is velocity over time. When you cross multiply, you get your v, which is a 3 multiplied by 5, which is 15. It means here is 15 in meter per seconds. Okay, so once we have this now, we can apply to use the area of trapezium to calculate for this distance, which is half this plus this multiplied by this, which is the height. You agree with me? This is 1 over 2. This will give us 128. 2 here 1, 2 here 64. Okay? That is 64 multiplied by 15. You're going to get 960. That is 960 meters. So the distance we are looking for is 960 meters. Okay? Hope you understand this. Thank you for viewing. Let's look at this. It says we should calculate the acceleration from this diagram. Acceleration. How? From this diagram, this is very important because it is corresponding to this. This is actually the final velocity. This is also important because this is the beginning of the velocity. That is the initial velocity. Okay? This is important because this is the time to attain this velocity. That is what was given to us as far as this question is concerned because acceleration is happening within here. This is constant velocity. This is deceleration. How do we calculate this acceleration? With this information given to us, you agree with me, this is v, this is u, this is t, this is a. We are asked to find. Among the 3 equations of motion, which of them is suitable for this question? If you think very well, you agree with me, v is equal to u plus at is the most suitable. What is v? Is 10. U is 2. A we are looking for. T is 2. That is 2 plus 2a. This is 10. 10 here. Bring 2 here. That is minus 2. This is 8 equals to 2a. Divide both sides by 2. 2 cancel 2. You agree with me? This is 4. A therefore is 4 meters per second square. So you can see it's not a difficult question. Hope this understood. Thank you for viewing. Let's look at this. It says a ball is thrown vertically upwards from the ground with an initial velocity of this. That is, we have u to be this. What is the total time spent by the ball in the air? A ball, say, somewhere here, must not be from the ground, was thrown, say this is the ground, this guy is standing on the ground, he threw a ball upwards. Okay? So the initial velocity it started with was 50 meters per second. Okay? So while it is going up, it is decelerating. What is that? Because acceleration means that what? Increase in speed, that is velocity over time. But while it was going up, the force of gravity was dragging it down. So if it started very fast, you agree with me, it will later come to rest. Once it comes to rest, it starts falling backward. So going up is actually deceleration. Okay? So it means the acceleration due to gravity is going to be negative. Okay? Acceleration due to gravity is going to be negative. So let's bring out the parameter from here. The initial velocity is 50 meters per second. We know that acceleration due to gravity is going to be negative, that is minus 10 meters per second square. We are looking for the time. First of all, it takes to go up. After we get that, remember, we are looking at the total time spent in the air. The total time spent in the air is the time it took it to go up plus to come down. Going up and down, they are always equal. So if we can get the time it takes it to get up, we can get the time it takes it to get down by multiply by 2 to get the total time. So we don't know this time it took it to get up. But the final velocity, because if I throw this thing up, this object up, for instance, or a ball, whatever, I started with initial velocity. Because it's going to stop. That means the final velocity is going to be 0. Remember, as it's going, it's actually decelerating. The reason for this minus, decelerating. The speed is coming down, it's coming to rest. And coming to rest before coming back is v therefore equals to 0. If you apply this formula, you agree with me, all these parameters are all represented here. Therefore, we can simply say the final velocity, which is this, u is 50 plus minus 10 multiplied by t, which is not given to us. That is 50 minus 10t. We bring 10t to the side, equals to 50. Now we divide t, therefore, is 5 seconds. That is the time it took it to get up. Coming down is also 5 seconds. So the total time spent in the air is 5 multiplied by 2, or we simply say 5 plus 5, which is 10 seconds. Okay? Hope you understand this. Thank you for viewing. Let's look at this question. It says a ball bearing is projected vertically, straight, upwards from the ground with a velocity of this. This is actually the initial velocity. So u is equals to 15 meters per second. Okay? What will be the final velocity? Final velocity will be equal to 0. How? Because while it is going up, it will later stop and come down. That going up, stop. That means the final velocity is 0. Now, calculate the time taken to return to the ground. As you can see, we first of all need the time it takes it to go up. Once we get that, we just double it. Because this going up and coming down, they have the same time. Calculate one to get the other one. Okay? We know g. This g going up is minus 10 meter per second square. Why minus? Because as something is coming to a rest, because as it's going up, it will later come to a rest. That is, the V is coming to a rest. It means it was decelerating. Just like the velocity time graph. As you are going here, you go like this. While you are coming to a rest, it means your velocity, final velocity, is going to be 0. Coming to a rest. Coming to a rest. It's negative, deceleration. So with this information now, we can write this to be V equals to U plus AT. What is V here? 0 equals to U is 15 minus 10 multiplied by T. We are looking for T. It means therefore 15, 10T. We bring this here, 10T equals to 15. We divide both sides by 10. You agree with me? T is 1.5 seconds. This is going up. Coming down is also 1.5 seconds. So the total time it will take to return to the ground is 1.5 plus 1.5 seconds. That is 3 seconds. So this is the total time it takes to go up and come down. All this understood. Thank you for joining. Let's look at it. It says a stone of mass 0.7 kg is projected vertically up with a speed of 5 meters per second. That is, the initial speed is 5 meters per second. Okay? Now, we are asked to calculate height. The h is not known. Remember, h this time is synonymous to distance as s. We don't know. Okay? We are asked to take g to be 10 meters per second square. Here, g is our a. But this, because we are shooting it up, is going to be deceleration. Why deceleration? Because while you are going up, you will later come to a rest. Anything that involves you coming to a rest, it means you are decelerating. Because you fly up and stop, then you start coming down again. That is what deceleration. Therefore, you are going to be minus under this consideration. We are told that when you calculate the maximum height, we should neglect the air resistance. Don't consider this because it doesn't matter when we are doing what? Motion. Whether it's 10, 1,000, 1 million kg. This value was given to us. The value it was used to fly. Okay? Now, we don't know T. The time is not given. We can get T. How do we get T? We know the G, we know the U. We can use that to get the time. If you look at the graph, it started from here to decelerate because this is deceleration. Where did it start from? 5 meters per second. Start falling till it gets to 0 meters per second. Here is the time. This is a distance which is equivalent to this height. Okay? First of all, we need to know the time between this and this. Because we already know G to be 10, this time we are not going to consider negative because we are looking at time. Time cannot be negative. So T, you agree with me, acceleration is V over T. So T therefore is equal to V over A. We swap, which is equal to V is 5 over A is what? 10, which is equivalent to this 0.5. Okay? In seconds. So we can say here is 0.5 in seconds. So we can use this formula and say S equals to UT plus 1 over 2 AT squared. This is H in this context because we are talking about height. We know the initial velocity to be 5 multiplied by this 0.5, the time, 1 over 2 multiplied by minus 10, because this is deceleration, this is deceleration, multiplied by 0.5 square. This will give us 2.5 minus this is 5. 5 multiplied by 0.25. This is 2.5 minus 1.25. If you work on this now, you agree with me, you're going to have 1.25 in meter. This is the height. The G, the only thing you should know is that once you project something up, because a time is coming, it will stop. That means it started very fast, the speed started reducing until it came to a rest. That is actually deceleration, which this represents coming down. It means it started very well and came to rest. We are looking for this height. Okay? As I said, you can use this. You can also use the area of this location. We already know that this is 0.5, right? You can use this area to say half base times height, because this is what? A triangle. You agree with me here? The base here is 0.5. Why the height is 5. It means therefore, if you cancel this, you have 2.5. 0.5 multiplied by 2.5. If you solve this, now I'm going to have 1.25. Just like this one. So any of them, you are good to go. Hope this understood. Thank you for viewing. Let's look at this. It says, what is the average velocity of the sprinter whose velocity time graph is shown in the figure below? Some students will rush and write 10 because this is actually velocity. You miss it. Once you see the word average velocity, that is to say the total displacement, that is the total distance over the total time. So therefore, we first of all must get the total distance. We already know the total time to be 10. What is the total distance? The total distance is the area under consideration. This is trickish. You will simply write 10, but remember average. This is not average. So to get the distance here, we need to get this area. That is half area of a trapezium. This to this. Here to here, you agree with me? 8 minus 2 will give us 6 here. Here to here. Why here to here is 10. So it's here to here 6 plus here to here. Multiply by this height, which is 10. Okay? Now, with this, we can get the distance. This is what? 16, 10. 2 here 1, 2 here 8. It means this time this is 80. So the total distance is what? 80 meters. Once we have 80 meters, the next thing now is to calculate for what? To calculate for the average velocity, which is the total distance over total time, which is over 10. This cancel this is 8. So the answer is 8 meters per second. As you can see, this is the maximum velocity. This is the average velocity. Hope this is understood. Thank you for viewing. Let's look at this question. It says, two particles S and Y starting from rest cover the same distance. The acceleration of S is twice that of Y. The ratio of the time taken by S to that taken by Y is what? Let's do the time one after the other before we find the ratio, okay? S and Y started from rest. That is, for S now and Y now, U here is 0, U here is 0. Starting from rest, that is what that word is revealing, okay? And they cover the same distance, okay? We don't know the distance, but same distance, okay? The acceleration of X, okay, is twice that of Y. Say this is A, this is 2A for acceleration, okay? With this information given to us, we are told that the distance covered are the same. It means we have to use this. Why this? Because all the information here are here. We know S was mentioned, This is 0. We are looking for t. Acceleration was actually mentioned, that is a, multiplied by t again. So this is 1 over 2 at squared. Okay? Remember, they cover the same distance. Okay? They cover the same distance. For this one now, its acceleration is 2 times this. So actually, what we also get here, that is for this guy, let's call this one y, let's call this one x, is this also 0, ut, plus 1 over 2. Here is 2a, because we already know that this is a, multiplied by t. And remember that this t is for x. So I'm going to put x here. Just to distinguish them, I will put y here. This one is y. Okay? Now, you agree with me, this is 2a tx over 2. This and this will cancel, have atx. This is sx. Remember, the question says that what? They cover the same distance. It means this and this are equal. Okay, that means this is equals to this, which means that ATS is equals to this. That is 1 over 2 AT. I am missing something. Supposed to put square here, square here, square here. This is also square. This is y from here. ATY square. Now we are looking for what? You look at this place now, you can simply say divide both side by a. A cancel a. We have t square over 2. We are looking for what? We are looking for the relation of s to y. S to y. So s to y. What I will do now? I will bring this down. If I say over 1, I will swap. That is t square x over t square y. Then 1 will go up here, 1 over 2. Okay? Remember, this is square, this is square. I can simply say this over this and make 1. This is 2, this is 2, that is square, square. Now, this over this is equal to the square root of 1 over 2. You agree with me? This is 1 over the square root of 2. If you rationalize the denominator, you have square root of 2 over 2. Remember, rationalize, you multiply the numerator and the denominator by this. This time this is square root of 2. This is square root of 4, which is this. So it means this ratio this is equals to, let me put it here, that means this ratio this is equals to the square root of 2 over 2. This is the answer. Hope this understood. Thank you for viewing. Let's look at this. It says a stone is released from height of 80. Let's say here. Let's say this is 80 meter. The stone is released from here. Okay? 80 meter above the ground. Calculate the velocity just before it strikes the ground. What is that? Remember, if I hold something like this, the initial velocity is 0. So as at this point, u is 0. So while it is coming down, the force of gravity is dragging it. It's actually accelerating because it's very fast. Although it will hit the ground, the velocity is high. But if it's coming to rest by itself, assume we threw it up, it will definitely go up and stop. But while it is falling, it is the air surface that obstructed its passing or its continuous motion. Therefore, it means that the velocity before it reached the ground is very high. So, this will be v, which we don't know. We know the height. Also, because it was coming down, it was accelerating. 0 going to higher velocity. So, it means we're going to consider the g as equal to 10 meter per second square. This is positive. If it is going up, this is negative. Question says, what is this velocity? You agree with me with all the information here now? You can quickly picture which of the formula among the three equations of motion, which of them is suitable for acceleration, speed, initial velocity, final velocity, and also the distance. As you can see, no time was given to us. Therefore, from what I am seeing, it is this that will be suitable. The final velocity we don't know. The initial is 0, 2, 10, 80. Okay? Then you say this is equals to 0 plus, this is 800, 1600. That is v squared now is equals to 1600. V is equals to the square root of 1600. So what do you think is this? That is v is equals to 40. Okay, 40. That is what? Our final velocity. If you don't want to solve it like this, no problem. You can simply draw the velocity time graph. Started from 0, I was accelerating very fast until it stopped. So we know that this is 10 meters per second. We don't know this v. We know that u is 0. We also know this distance to be 80. That is the area under consideration. You don't need to worry yourself. Just draw out the triangle. Okay. What is this height? This height is the v we are looking for. Okay. Why this is the time? We don't know the time. Okay. Because this acceleration is equal to velocity over time. So time is velocity over acceleration. You swap the position. Okay? So therefore, velocity, we don't know. We know acceleration to be 10. So in place of this t now, because this is t, we put v over 10. Okay? Now, to get this area is our base, that is our base, this is the base, v over 10 multiplied by the height, which is also v. This area, which you are calculating here, is equal to the distance, which is 80. Say this one is equal to 80. Okay? This and this is v squared. This is 20 equals to 80. V squared now, you cross multiply, is 80 multiplied by 20. You agree with me that is 1600? 1600. So v now is equal to the square root of 1600. So v is actually 40 in meter per second. The way we got it here, v, meter per second. So you can see, either you use this method, you are good to go. Hope this is understood. Thank you for viewing. Let's look at this question. It says, a body falls freely under gravity, g equals to 9.8 meters per second, from a height of 40 meters to the top of a platform 0.8 meters. Two of them above the ground. It means this is a height. This height, if you look at the ground, is 40 meters from the ground. Also, there's a platform is going to fall upon. Let's say this is a platform. The platform is 0.8 meters above the ground. The next thing is, you must put at the back of your mind, or you should recall, when an object is falling, it's accelerating. Don't look at the word falling. This word falling does not have anything to do with velocity, speed, whatever. Falling is just English description. But what is actually going on? There is acceleration due to force of gravity that is dragging it down. If this obstruction was not there, the body will continue to fall. But if an object is going up, is actually decelerating, because anything that will make you come to a standstill without touching anything, because you are the one that stopped by yourself as a result of the gravity, you were going up, you stop and start coming back. That's stopping. It means you started on a high speed, the speed start reducing until you came to a rest before you start coming down. By going up slowly to zero velocity, it means you were decelerating. So it's not the pictorial movement of, oh, this is deceleration. No, this is actually acceleration. While up is what? Deceleration. The reason is because you need to know if this value you are going to use is going to be negative value or positive value. Because it's coming down, our G is going to be positive G. So our G will be positive G, 9.8 meter per seconds. Okay, now, we know the height. The height now is from here to here. That is to say 40 minus this. You agree with me? This is 39.2 meter. That is from here to here. By saying what? 40 minus 0.8. You agree with me? If you subtract this, you're going to have 2 here. 9, 3. It means, therefore, our S, the distance covered, is 39.2 meter. The time was not given to us. G is given to us. We are asked to find the final velocity. We know the initial velocity to be 0 because something you heard, you released your hand. It means before it started, it was 0. Okay? So you did not apply any force on it. Okay? So the starting point was 0. So we are going to use this formula, which you can rewrite as, okay? So what is v square? We don't know. That's what we are looking for. We know this to be 0. 2 multiplied by 9.8. The distance, which is S, is this. That is 39.2. If you work this out, I'm going to have 768.32. So you simply do V, therefore, is equal to the square root of 768.32. So what is this? 27.7 in meter per seconds. This is our velocity. Okay? Let's look at this. It says the diagram below shows the velocity time graph of a vehicle. Its acceleration and deceleration respectively are what? Let's see. This is the acceleration side. This is the deceleration side. Okay? We don't have issue. Remember, acceleration is always velocity over time. We know this velocity. So A therefore is 80 over 20, which is 4. So A therefore is 4 meter per second square. For the deceleration, this time the same thing, but we are going to get a negative value because it will be going down. That is 80 over minus 80 over. What is this? 90 minus 50 to get the differential. That is 40. You agree with me? This is 2 minus 2 meter per second square. Okay? Hope you understand this. Thank you for viewing. Let's look at this. It says a mango fruit drops from a branch 10 meters above the ground. Just before hitting the ground, its velocity is what? Its velocity is what? Before reaching the ground. No problem. We know the distance to be 10 meters. When it was here, before dropping, it was actually at rest before coming down. So from rest, U is 0. Our G is, because it's coming down, it was accelerating down. Going up is deceleration when it comes to object. We are looking for the final velocity before reaching the ground. With all this information, you agree with me, we have to use this formula. So we are looking for V. We know this to be 0, 2 multiplied by A. A will be our G here, which is 10 multiplied by the distance, which is also 10. This will give us 200. So V therefore is the square root of 200. You agree with me this is 40.14 in meter per seconds. So this is the answer. The graph below shows a velocity time graph representing the motion of a car. Okay? Accelerate, constant velocity, decelerated. Find the total distance covered during the acceleration and retardation period. Not all the distances. Is this distance all the acceleration and all the deceleration? This area plus this area will give you the answer you are looking for. Okay? First, here is 10. That is our V. That is actually the height. So to get this now is half base times height, which is equal to 1 over 2 multiplied by the base here to here is 10. Height is also 10. That is 50 when you work on this. For this one, it's also half base times height because it's also a triangle, which is 1 over 2. Here to here, we don't believe that this is half of this. So here to here, let's call it 45. It means here to here now is 5. So the base is 5, the height is still 10 because height, same. So here is 25. So the total distance under this and this, you will agree with me, is 50 plus 25, which is 75 meters. So this is the final answer. Hope you understand this. Thank you for viewing.